pattern that we get with similarity and perimeter is not found as well for similarity and area. Okay, so same thing as the other one. I'm gonna actually use squares here. Same thing. Okay, so I'm gonna use a square here. Okay, just so I can make my life a little bit easier. But I want you to really see that it won't be the exact same pattern. It's actually a little bit different for when we deal with area. So let's go ahead, and I'm just gonna call this side length 1 because you know that it's a square, so that means all the side lengths are the same. For the second one, I'll call it side length 2, but I'm going to go ahead and say that these are in fact similar to each other. So what that means is that there is a scale factor, and I'm going to go ahead and just call it SF for scale factor. So I can go ahead and I can rewrite all of these new S's by definition by saying S1 times scale factor. So equals S1 times scale factor, same thing, okay? So technically all I'm doing here is just rewriting it based off of the fact that they're similar, so they all have the same scale factor, and you would just multiply, okay? So what I'm going to go ahead and do now is calculate the area. So area of a square, right, we know, or I hope you know, it's just going to be the two sides being multiplied to each other. So side 1 times side 1, right? You can even, if you really want to, you can write this as side 1 to the second power, but honestly, it doesn't really matter, okay? Now let me go ahead and show you the area for this for the second square. So area for the second square is going to be equal to side 2 times side 2, but we know that we can rewrite the side 2 with using side 1. And so this is going to equal to, instead of writing side 2, I'm going to equal to side 1 times scale factor times side 1 times scale factor. Okay, so just remember, these are just numbers being multiplied. Since I don't know what the numbers are, I'm using a variable. Okay, so we're technically almost done to show you that it's not the same pattern, okay? So then what we can go ahead and do is just try to group it something like this, where the two sides ones are next to each other. So all I'm going to do is just rewrite these. If you notice, everything is being multiplied, so that means I can change the order of it. It's sort of like saying, like, 3 times 4 times 5 is the exact same thing as saying 5 times 3 times 4, right? The order really doesn't matter when you're multiplying and when you're only multiplying. So I'm going to go ahead and do scale factor times scale factor times side 1 times side 1. So all I did was just rearrange them. Now, if you noticed here, side 1, side 1, side 1, side 1. So what that means is I can go ahead and I know that that's how they relate to each other. So this is going to be like the area of the first square. Okay. And now notice how I have these two extra things now. When I had to deal with perimeter, I only had one extra SF in the front. So what this means is that it'll be SF to the second power, because x times x is x to the second power. And so here you go. This is how they relate to each other. Whenever you have a dilation or a similarity, the area doesn't only change because you only multiply by the scale factor one time, but rather you multiply the scale factor with itself and then you multiply the area. So just to give you a quick example on how to use this and how different this is, okay? Imagine that you have a square with area, let's say 16 units squared. Okay, and then let's say that I'm going to dilate it by a scale factor of, let's do 3, just because it's a number. Okay, so since this is bigger than 1, I know it's going to be an enlargement. So what that means is that in order for me to get the area of the new square, I am not only going to multiply it by 3, because that's not what the equation is saying. The equation says take the scale factor, square it, and then multiply with the old area, which is going to be 16. So then that means it'll be 9 times 16, our new area. So just know that this is super different than perimeter. Perimeter, you just multiply by the scale factor and that's it. This one, you're going to have to square it first and then go ahead and do it. And this just comes from the fact that, area has a different equation than perimeter. But it's something that it's really nice to know, because then you can you can understand better how like equations or how these rules are made up. Not because somebody just decided, but because we're using the super basic equation of area for a square, which is just length times length, which is the sides. We can easily do this for a rectangle and it'll prove the exact same thing for a circle, triangle, whatever.